Throughout history, humanity has been captivated by the cosmos. The twinkling stars and vast expanse of space have ignited our imaginations. Today, that dream is transitioning from fiction to reality. What was once relegated to the realm of imagination is rapidly becoming our future. We are on the verge of a new era, one where humanity will venture beyond Earth to make space our home. This is not just a technological leap, it's a pivotal moment in human evolution. Leaving Earth is no longer a question of if, but when. The countdown has begun. The journey towards space colonization has been a long and arduous one. Early pioneers dared to dream of a day when humanity would break the bonds of Earth's gravity. From the groundbreaking Apollo missions to the ongoing research aboard the International Space Station, each step has brought us closer to this goal. Today, space agencies and private companies around the world are engaged in a new space race. Driven by innovation and a shared vision, they are developing the technologies that will make space travel more accessible and affordable. Reusable rockets are becoming the norm, significantly reducing the cost of launching payloads and people into orbit. This new era of space exploration is characterized not just by government-funded programs, but also by the emergence of private companies. These pioneers are investing heavily in space tourism, asteroid mining, and the development of permanent off-world habitats. While the challenges of living in space are significant, they are not insurmountable. Scientists and engineers are working tirelessly to develop innovative solutions to the problems posed by microgravity, resource scarcity, and radiation exposure. Artificial gravity environments, advanced life support systems, and radiation shielding technologies are just a few examples of the breakthroughs that are making space colonization a real possibility. We are on the cusp of creating self-sustaining environments where humans can not only survive but thrive. Beyond the scientific discoveries and technological advancements, it offers humanity a chance to secure its future. By expanding beyond Earth, we can mitigate risks such as climate change, resource depletion, and potential global catastrophes. It is about pushing the boundaries of human potential and venturing into the unknown. The final frontier awaits, and we are ready to answer its call. The journey towards establishing a human presence in space began in earnest in the mid-20th century, fueled by a potent mixture of scientific curiosity and geopolitical rivalry. The launch of Sputnik 1 by the Soviet Union in 1957 sent shockwaves across the globe, marking the beginning of the space race. The United States, determined not to be outdone, responded with vigor, pouring resources into its fledgling space program. The National Aeronautics and Space Administration, or NASA, was formed in 1958, solidifying America's commitment to conquering the final frontier. The Apollo program, undoubtedly one of the most ambitious scientific endeavors in human history, captured the world's imagination. The grainy black and white images of Neil Armstrong taking one small step on the lunar surface in 1969 remain etched in collective memory, a testament to human ingenuity and the indomitable spirit of exploration. While the Apollo mission successfully landed 12 astronauts on the moon, they were ultimately short-lived excursions. The focus soon shifted towards establishing a more permanent presence in space, one that would pave the way for future exploration and scientific discovery. As the fervor of the initial space race subsided, a new era of international collaboration began to emerge. The International Space Station stands as a testament to this newfound spirit of collaboration, a joint project involving the United States, Russia, Europe, Japan, and Canada. The ISS has hosted astronauts and cosmonauts from around the world, conducting invaluable research. It has allowed us to study the long-term effects of spaceflight on the human body. The station has enabled a wide range of scientific experiments. The knowledge gained has advanced our understanding of the universe and benefited Earth. The dawn of the 21st century witnessed a paradigm shift in the landscape of space exploration. Private companies, once relegated to the sidelines, emerged as major players, injecting new capital and innovation into the industry. Companies like SpaceX, founded by Elon Musk and Blue Origin, led by Jeff Bezos, have revolutionized the economics of spaceflight. Their reusable rocket technology has significantly lowered the cost of launching payloads and humans into orbit, making space more accessible than ever before. These private companies are not merely focused on reducing the cost of space travel, they are actively pursuing ambitious plans for the future. SpaceX, for instance, aims to establish a self-sustaining colony on Mars, while Blue Origin envisions a future where millions of people are living and working in space. This surge in private sector involvement has injected a renewed sense of excitement and urgency into the quest to expand humanity's footprint in space. The competition fostered by these private companies, coupled with their willingness to take risks and embrace innovation, has accelerated progress towards making space colonization a tangible reality. The environment of space presents a unique set of challenges to human physiology, with microgravity being one of the most significant hurdles to overcome. On Earth, we are constantly subjected to the pull of gravity, a force so ubiquitous that we rarely even notice its influence on our bodies. However, in the weightless conditions of space, our musculoskeletal and cardiovascular systems begin to adapt, often with detrimental consequences. Without the constant resistance provided by gravity, muscles atrophy, bones weaken, and even our cardiovascular systems become less efficient. Astronauts aboard the International Space Station, despite rigorous exercise regimens, experience significant muscle and bone loss during their missions. To mitigate the adverse effects of microgravity, scientists and engineers are exploring a range of innovative solutions. Artificial gravity environments created by rotating spacecraft or utilizing centrifugal force could provide a more Earth-like gravitational pull, helping to maintain bone and muscle mass and ensuring proper cardiovascular function. These technologies aim to provide the necessary resistance and stimulation to maintain astronaut health and fitness, paving the way for extended space missions and eventual colonization. In the unforgiving environment of space, resources are scarce and precious. Unlike Earth, where we are surrounded by an abundance of air, water, and food, space habitats must operate as closed-loop systems, constantly recycling and regenerating vital resources to sustain human life. Water, the elixir of life, becomes a critical resource in space. Advanced life support systems aboard spacecraft and future space habitats will need to capture and purify every drop of wastewater, sweat, and even urine, transforming them back into potable water. Food production in space presents another significant challenge. Traditional agriculture, reliant on vast tracts of land, sunlight, and abundant water, is simply not feasible in the confines of a spacecraft or a Martian habitat. Instead, space colonists will need to embrace innovative farming techniques, such as hydroponics and aeroponics, where plants are grown without soil, utilizing nutrient-rich solutions and artificial lighting. These space-based agricultural systems will not only provide sustenance but also contribute to the life support system by generating oxygen through photosynthesis and recycling organic waste. Beyond the protective embrace of Earth's atmosphere and magnetic field lies a constant barrage of cosmic radiation, a silent and invisible threat to human health. This high-energy radiation, originating from the Sun and distant galaxies, can penetrate spacecraft and human tissue, damaging DNA and increasing the risk of cancer and other radiation-induced illnesses. Protecting future spacefarers from this invisible enemy is paramount to the success of long-duration space missions and the establishment of permanent off-world settlements. Spacecraft design plays a crucial role in mitigating radiation exposure. Utilizing radiation-hardened materials in spacecraft construction can help absorb and deflect incoming cosmic rays. Additionally, incorporating dedicated radiation shelters within spacecraft and future space habitats provides astronauts with a safe haven during periods of heightened solar activity, such as solar flares, when radiation levels spike dramatically. Beyond physical shielding, researchers are exploring innovative approaches to radiation protection, including magnetic shielding technology that could deflect charged particles away from spacecraft and habitats, much like Earth's magnetic field protects us. By developing effective radiation countermeasures, we are paving the way for a future where humans can live and thrive beyond the protective cocoon of our home planet. Venturing into space presents physical and psychological challenges for astronauts and settlers. Isolation, confinement, and separation from loved ones can affect mental well-being. Creating community and designing pleasant habitats are essential. Virtual reality can connect colonists with Earth and loved ones. Addressing psychological needs ensures mental well-being and thriving in space. The Moon, Earth's celestial companion, beckons as the first logical step in humanity's journey to establish a permanent presence beyond our home planet. Its proximity, a mere 3-day journey by spacecraft, makes it a relatively accessible destination for exploration and resource utilization. Future lunar outposts, envisaged as both scientific research hubs and gateways for further space exploration, will mark the beginning of a new era of human expansion into the cosmos. Early lunar habitats will likely be built with modular structures, prefabricated on Earth and assembled on the lunar surface. These modules, designed for both functionality and crew comfort, will house living quarters, research laboratories, life support systems, and communication arrays. Shielding from solar radiation and micrometeoroids will be paramount, with lunar regolith, the Moon's loose surface material, offering a readily available building material for radiation shielding. Harnessing the power of the sun will be crucial for sustaining these lunar outposts. Water ice, believed to exist in permanently shadowed craters at the lunar poles, could be extracted and processed to provide drinking water and oxygen, further enhancing self-sufficiency. Red Planet pioneers building a home on Mars. Mars, the red planet, has captivated the human imagination for centuries as a potential second home for humanity. Its thin atmosphere offers some protection from radiation, and its day-night cycle is similar to Earth's. Establishing a self-sustaining colony on Mars represents the next giant leap in space colonization. The challenges of Martian colonization are immense, but not insurmountable. Early habitats will likely be underground, using natural caves or excavated shelters. These dwellings, powered by solar or nuclear energy, will serve as a sanctuary for pioneers. Creating a breathable atmosphere and a sustainable food supply is paramount. Scientists are exploring the feasibility of terraforming Mars. Enclosed biodomes could provide a controlled environment for crops and oxygen. As the colony grows, it will need its own infrastructure and transportation systems. Martian cities connected by tunnels or surface networks could emerge. The red planet could become a thriving hub of human civilization. Orbital oasis, designing cities in the sky. Beyond the gravitational pull of planets, a new frontier awaits, the vast expanse of space itself. Orbital space habitats, often envisioned as massive rotating structures, offer a unique opportunity to create artificial worlds tailored to human needs. These celestial cities could become hubs of scientific research, industrial manufacturing, and cultural exchange. One prominent concept is the O'Neill cylinder, a rotating structure generating artificial gravity. This habitat could house millions, simulating Earth-like gravity and day-night cycles. Vast windows would offer breathtaking views of Earth and the cosmos. These orbital oases could become thriving centers of civilization. Section 4. Architects of the Cosmos. Shaping the future of space habitats. Designing habitats for space requires visionaries, architects of the cosmos. These experts blend architecture, engineering, and psychology to create functional and inspiring spaces. They tackle challenges like radiation shielding and artificial gravity. Utilizing in-situ resources and sustainable design is crucial. Addressing the human element is essential. Spaces must foster community and connection to nature. Biophilic design can mitigate stress and isolation. Innovation and collaboration define space architecture. Architects, engineers, and artists will design habitats for a spacefaring civilization. These structures will shape our future in space and our understanding of humanity. The next 3 decades. Laying the foundation, 2025 to 2055. The year is 2025. The Lunar Gateway, a space station orbiting the Moon, is launched. This marks the start of a permanent human presence beyond Earth. The Gateway will be a hub for lunar operations and deep space missions. Robotic missions scout the lunar South Pole for resources. By the mid-30s, Artemis Base Camp takes shape. SpaceX prepares for the first human mission to Mars. In 2033, humans land on Mars. Billions celebrate this achievement, inspired by human ingenuity. Towards Martian independence, a century of expansion, 2055 to 2100. By 2055, the lunar surface is no longer desolate. Artemis Base Camp has expanded into a bustling lunar settlement. On Mars, the first human colonists adapt to their new home. They cultivate crops within inflatable biodomes. Advanced propulsion systems make Mars travel safer and more affordable. By century's end, a self-sustaining Martian civilization begins to take root. Beyond 2100, the multi-planetary era. As we venture beyond the year 2100, the timeline becomes a tapestry of possibilities. The 22nd century holds the promise of further expansion into the solar system and beyond. Perhaps we will establish outposts on the moons of Jupiter and Saturn, their icy surfaces harboring the building blocks of life. The challenges of interstellar travel are immense, requiring breakthroughs in physics and engineering. Yet, humanity possesses an unyielding spirit of exploration. What seems impossible today may become the reality of future generations. The future of humanity lies among the stars. A future among the stars, the next chapter of humanity. The journey ahead is daunting, filled with immense challenges and unparalleled opportunities. We will be tested, our ingenuity and resilience pushed to their limits, but the rewards are immeasurable. The expansion of human knowledge and the fulfillment of our desire to explore. This journey requires global cooperation, technological innovation, and belief in the human spirit. The future of humanity is not confined to this planet. We are on the verge of a new era, venturing into the cosmos as a multi-planetary species. The final frontier awaits, and the future of humanity is calling.